Welcome to Meet the Oracle Masters, the online series. This time with Jim Czuprynski, Oracle Ace Director, based in Chicago. Quite early for him to get up for us. And yeah, well, Jim, take over the screen and take it away.
Can do. Okay. And I want to do that. Let's see if this works. Huzzah! There we go. Good morning, everyone. So my name's Jim Czuprynski. Yes, it's a Polish last name. And yes, my family's originally from Poland. So I'm a popular speaker at the POUG, generally there, and also because I love beer. But today I'm here coming in from the United States. It's a beautiful spring morning here. And talking about a feature of the Oracle database that's actually been there since 18C called Fast Ingest and his cousin, Fast Lookup. So a little more about myself, by the way. I've been doing IT for roughly 4 decades. I started out as a mainframer. In fact, I remember the first serious job I had, the guy said, "You're really lucky. This week, we just changed over from Hollerith cards." So I've been around a bit and I've seen a lot of changes, right? About 20 years ago, I became an Oracle DBA. I got serious about it for about 5 years, worked towards my first OCP. It took me 2 years to get my OCP designation, going to night classes while working full time. You know, I try to keep that up to date as I show here. Been an ACE director since 2014. So I guess I'm starting my 7th year this year. And that's been able to take me around the world, literally. I think I've touched every continent except Antarctica. And if they ever get an Oracle user group down there, I'll be one of the first people to go. I'd love to see it, right? I also spend a lot of time these days. I don't really work full time anymore. I'm a board member for OD Tug. We're really excited about Kscope 21 coming up in, my gosh, I think 6 weeks. I guess I better get my presentations done. And I also spend time editing Techceleration, which is OD Tug's database, platform, community, if you will, portal really for content. If you're interested in writing articles, and again, articles typically run between 1,500 to 2,000 words of any technical depth, anything to do with database applications or the database itself. Would love to hear from you on that. I do have a blog. I wish I blogged more. As I mentioned, I've spoken quite a bit. I also, I'm not sure exactly where to put this in here. Somewhere I should have put it in here today. I have a podcast now with my colleague Liron Amitzi, who is originally from Israel, but now lives in Vancouver, British Columbia, in Canada. And it's called Beyond Tech Skills. You can go to beyondtechskills.com. I think we're just posting our 7th or 8th episode today. It's going to be an interview with Kellen Povan-Gorman. And we've done an arc about basically how to do interviews from both candidate and interviewer's perspective. Because let me tell you, one of the hardest things in our business is, in IT specifically, is to find good people. Right. And also to get hired sometimes, right? It's a little easier these days because of the demand, but we really are trying to touch on that, if you will, softer skills side of IT. So if you get a chance, check it out. If you want to reach out to me, you can follow me on Twitter, check me out on LinkedIn. This email address, jczuprynski@zerodefectcomputing.com. I love it when people say, "What's your email address?" I just go, "Ugh, if you think my last name's hard, wait till you see my email address." Hey, it's what they had. That's the company I actually represent today, Zero Defect Computing, my own company. Enough about me. Let's get to the meat of the matter. We're in a very interesting place in the world today. Why are you not advancing? There we go. That's better. Where are we? Well, where we are today, it's quite fascinating. Here, especially in the United States, we're undergoing, as a result of you know, an overdue change, some immense opportunities. The way I tell people today that if you're in IT, you're like, it's almost as if you were at Bastogne in World War II, right? You're completely surrounded by the enemy and you can attack in any direction. And IoT, in my mind, is one of the things that we're going to continue to see rise in the industry. Almost everyone's talked about IIoT, in the industrial Internet of Things, right? You can't walk into a modern factory today and not find something that's hooked into a sensor, right? But there's a lot more coming. Before he decided to host Saturday Night Live here in the United States this coming weekend, don't know why Elon Musk is doing that, he offered up a carbon capture prize, right, for devices that can actually sequester, capture CO2 and push it back down into the ground. The new idea of ambient artificial intelligence, stuff that essentially makes things look like a very intelligent bot that you're talking to, right? A chat bot is something that's also relatively new. If you're in any major US city these days, and I'm sure it's the same for you folks in Amsterdam and across Europe, smart cities, your cities are much smarter than ours, but we're at the point in the US especially where we're going to see a revolution here. I was in San Antonio a couple of years ago in Texas, and everywhere you go, there's scooters. Little electrified scooters, right? Electric bicycles. You could not get your hands on an electric bicycle, much less a bicycle here in the US during the COVID-19 challenge, right? And we're getting vaccinated and things are getting better, right? But still, people have discovered the advantage of bicycling to get to and there, right? And again, in Europe and Asia, this is nothing new. One of the more interesting aspects of edge computing is traffic flow. I saw a recent article that estimated in the United States alone, we waste $7 billion US on nothing but waiting at traffic lights. Now, again, not everybody has an engine in a car that shuts itself off waiting at traffic stops. So there's an incredible opportunity there to improve the environment, right? Autonomous delivery vehicles, there's another opportunity, but a major one here in the US especially, and really across the world, is farming. Using drones to look for parts of plantings. I'm heading up to Wisconsin right after I finish our talk today with you folks, which is just north of Chicago. And everywhere you go, right, farmers are planting their fields. And this is a critical time of the year to get the crop established, but you don't want to overwater and you don't want to underwater, right? I actually saw a really interesting one, I didn't even have space on here, was for a robotic weeder that is being experimented with here in the United States that actually uses laser beams to zap weeds, because weeding is an incredibly manual process, right? So we're starting to see that happening here. But even simpler things, McDonald's, the food conglomerate, right? Fast food conglomerate here in the United States actually started installing cameras in dumpsters to make sure that people are using them appropriately for recycling. We've got a major move on now to reducing food waste here in the United States. We estimate that 15% of all food is wasted. And what are we going to do with food that's wasted? Well, compost it, right? So there's a major move in that regard as well. But the final one here is down in this lower right-hand corner, excuse me. This is a young lady who's a farmer in India. And it's very likely that if we don't get climate change under control, that farming is going to become an extremely dangerous occupation in India. Temperatures are starting to range during summers at 35 centigrade and 100% humidity. People die in those conditions. So we've got an enormous amount of opportunity, an enormous amount of challenges as well. And I see IoT as being one of the ways to gather all that information. Here in the United States, thankfully, with change in administration, we've also got a change in mentality. But finally, hopefully, we'll have a national infrastructure bill. It's been talked about for 5 years, actually for much longer than that. But there's now an impetus to move towards this strategy, which, again, not everyone agrees with this, but electrifying everything. I'm working on a kitchen remodel right now. I'm planning it now. I'm going to all electric appliances. I like cooking with gas, right? But electrical appliances make more sense. They're much more economical. Right now in the US, renewable energy costs for wind and solar especially, are cheaper than natural gas and coal, much cheaper than coal, right? So there's a major shift there. Nuclear technology is changing. This is an actual picture of a nuclear technology up here in the right-hand corner that can use spent nuclear fuel from typical water-cooled reactors. Yeah, so nuclear waste can be less of a challenge. Here in the US, we've seen major changes with electrical cycle demands. People are working from home a lot more, and they're probably going to continue to work from home. I have a neighbor in my immediate neighborhood has 2 Teslas, not 1, 2 Teslas in his garage, right? And he's got the power hookup and everything else like that. So the idea of using the battery power that you put in a wall unit for storing that energy is now starting to be used as a secondary storage facility, a virtual power plant, if you will, for excess renewable energy. And at the center of all this are things like green hydrogen, right? I just saw a news story in, I think, BBC that there's a couple of older oil and gas platforms in the North Sea that are being discussed of being converted into wind tower centers, right, that they can use to electrolyze seawater into hydrogen and oxygen. And this is the idea of green hydrogen, using hydrogen as essentially a storage medium rather than a battery. And then finally, smart meters. And that's going to be the major thrust of the rest of my presentation here. Smart meters we have here across the United States. We just got one in our home about a year ago. And essentially what it says is, hey, your local utility will say, you know, it's going to be a really high demand period today. We're going to have a lot of demand for air conditioning, for example. This is going to be a hot day. Would you mind not running your air conditioner at 68 degrees Fahrenheit, right? Run it at 72, run it at 74, turn on a box fan instead. We'll give you a credit on your electric bill, right? So all these types of things, especially smart meters for monitoring consumption at a household or by household basis or a business by business basis is where we're headed. So it looks like we're headed towards an electrical future. And that, my friends, gives us an opportunity because Oracle, the database itself, the platform itself, has this great thing called fast ingest. And if you think about all the things I've talked about during that rather long introduction, every single one of them has some need for data to be stored. And just for an example, smart meters, I've mentioned that already, right? And I'm going to focus on that as our major example coming up here. But social media feeds, right? Stuff from Facebook, stuff from Twitter, from Instagram, from whatever, right? Snapchat, whatever other tools are being used. CCTV images, right? It's not quite as ubiquitous in the US as it is in, say, the UK, but you know, all these types of things, right? There's huge volumes of sometimes quite large payloads, but generally very, very small payloads, certainly under 256 bytes in many cases. And they're happening all the time. So imagine if we had a way to store them effectively inside a database. Welcome to fast ingest. Here's the idea behind fast ingest. We insert data into a database. However, we don't use the standard transaction methodology to insert them. Here's a concept: eventually insert it. Now, again, we have ways we can insert things very quickly. Let's put it this way: they're inserted, but eventually they're actually added, written to the database, because that's what this is all about. So if you have huge amounts of data coming in, and I'll show you some examples of exactly what I'm talking about here in just a little bit. What happens is we allocate part of the large pool called the memory optimized row store, which again has been around since 18C. We batch the rows up inside this MORS, I like just calling it MORS, inside the MORS. And then a series of background processes drain this series of rows, batches of rows, there we go, that's better, and write it into the database tables. We also have a mechanism to verify that synchronicity has occurred. But most importantly, if I said commit at the end of that transaction, it means nothing, because commit means nothing for a table that's been enabled for fast ingest. Here's a little bit of a look of the platform I'm going to use, or the scenario I'm going to use, right? What I did is I built a simulated series of smart meter payloads. I wrote a PL SQL procedure. I used Swing Bench to insert rows very, very quickly into the mem-optimized row store from multiple sessions. That's one of the things I love about Swing Bench, right? Is that I can generate, multiple sessions. I think I ramped up to 25 different sessions, just basically hammering against the database with this, right? I'm using the good old DBMS random to go ahead and build the transactions for a series of smart meters. And then I let this baby go and add data into a table called T meter readings. That's basically the whole test case that we're going to look at today. So again, a way to measure whether or not fast ingest actually is effective as we would think it is, right? So here's my basic schema. I have a table called smart meters, really an entity called smart meters. What does it have? It's a bunch of data about individual smart meters. And I actually captured this data from the city of Chicago's public licensing data that's available via API. And I grabbed about 55,000 individual businesses for which I had information about how they were licensed, what type of work they did, and their location. That's key. For the last slide I'll share with you. I also then generated data for the meter readings table. And then this business descriptions table is actually just really a little table of separate business descriptions that let me classify businesses, really the smart meter consumer, into what they do. So I can do some interesting analysis with this, right? Because just capturing data, how boring. How boring is this? By the way, I used two different test environments. One was on a separate hard server in my office. It's right behind me, right there. And the other one was a 21C DBCS instance, right? What we would typically call, not bare metal, but a virtualized 21C database instance, 21.1, if I remember correctly. A little bit more technology behind it. 30 gigabytes of memory, 2 CPUs. Notice I only have one virtual CPU. So I use really test environment 1 to build out my test cases, and then test environment 2 to really hammer against the database and see how this all worked. Why 21C? I've got some other things I'm going to be experimenting with in the future, and I wanted to get a chance to look at some of the other data types that are inside there, like the new JSON data type, even though I don't use it specifically for this case. But now you've got a pretty good feel for what I'm going to attempt to share with you. So let's go ahead and get started. My first attempt, prior to using these two experiments, I wanted to share this with you, was with an autonomous transaction processing instance, an ADB, autonomous database instance, right? ATP, autonomous transaction processing. Screams, please use fast ingest. So I went in, did an alter system set for mem optimized pool size. This has to be done. I set it to 2 gig, has to be done, and then bounce the instance for it to actually take effect, because we're reserving part of the large pool for that mem optimized row store, or the MORS, as I like to call it. So I did that, and then I went ahead, and after the instance bounce, I said, show me anything that has parameter of pool size. Oh, there it is. Okay, excellent. I'm going to go change over to my container, because this is a 19C database and I use PDBs, right? So I shift over to my container, and let's go ahead and turn this table on for, this is the way you activate a table for write. Mem optimized for write, for fast ingest, right? And what do you mean I can't use this on an encrypted table space? How stupid is this? Unfortunately, it's a current limitation. It is a limitation that, from talking with the product managers over at Oracle, is likely to be lifted quite soon. So by the time that you see this recording, it might already have disappeared. But there's a reason for this. And it's mainly because it's just not part of the feature set just yet. But again, this is one of the top things that Oracle's working on getting rid of. And there's a few other limitations that we'll talk about in just a little bit. So here I am at a dead end. I can't use ATP. So what did I do? Well, as I said, I built my test instance on a server here in my office, and then I went and built a second one on a 21C DBCS instance up in the cloud, right? By the way, if you want to see what is fully supported, here's a great Moz note. It really comes in handy for understanding what its limits are, right? So now, what did I have to do? Well, here's another little limitation. These features are Exadata only. Now, that doesn't mean you couldn't use an autonomous transaction processing or an autonomous data warehouse instance for it. And it actually doesn't mean that you can't experiment with it, even if your database isn't running on Exadata. Old trick, my friend and colleague, Julian Donchef, found this, knew about it, and I caught it in one of his presentations. Like, why didn't I use this? You can set _Exadata _feature _on to true. Warning. Hear me now. Listen to me forever. Do not do this in production. This does not turn on all of the features. There are certain things that you do by turning on Exadata feature on to true that you will get errors, okay? Because some of it is actually related to Exadata storage capabilities itself. So for example, if you decided to try this to run experiments on automatic indexing, you would see some errors in the resulting reports. It's because this is not a complete activation of Exadata features. It's only for simulation purposes. But once I did that, now I'm ready to proceed, right? So I've got either my 19C or my 21C instance. I turned that on. And what? Now what? Well, here's another thing. There are very specific limits for even the tables themselves on what are allowed to be activated. And in this case, my T meter readings table had a foreign key constraint against my smart meters entity, right? My smart meters table, because I'm a good DBA, aren't I? I'm going to put a foreign key relationship there. Not so fast. Here is a more complete list of all the things that are limited as it stands right now. And by the way, where is it about halfway down? If it's stored within the table itself is stored within an encrypted table space, not allowed yet. Again, I understand this is changing. It will eventually change. The product manager himself said, we're working on it. That was about 3 months ago. By the time you see this, it might have already have changed. But notice that most of these exceptions, if you will, or limitations, right? By the way, there's a Moz note here that gives you all of the limitations so you can understand which ones are there before you try doing something. Many of these really make sense because our intent here is, here it is, get it inside the database as quickly as possible. So many of these restrictions actually sort of make sense to me, right? The encrypted table space one, not so much. That's one I would really like to see go away first. But some of these others like range or hash partitioning, no, you can't really use it on a range or hash partition table, right? There's only certain, I'm sorry, scratch that. Let me rewind that. You can use range or hash partitioning. Yes, that's allowed. Sorry, I saw the green yes there. But reference, interval, system, auto list, most of those partitioning methods are prohibited, right? As I showed you in that last example on the last slide, foreign key constraints, nope, can't have them on that particular table, right? And I'm not going to read this list to you, that would be insulting, but be aware of these limitations. If you bump up against one of them, go, oh, that's right, Jim said, the whole idea is to drink from a fire hose. So just so that you know what most of the limitations are. A little bit more of information is important here, the transaction thing. Okay, our goal here is to get rows inserted into a table as quickly as possible. We're bypassing the normal transaction methodology. I'm not going to read all of this to you, but I want to highlight a few things. Commit means nothing. The drainer processes are the ones that actually write the data into the database. So there's no commit, ain't no rollback either. So you got to think about this when you're building this out, right? To make sure that you don't want to lose connectivity between the database and the application that's serving up these rows, whatever that is, right? It is possible to lose data. It is possible, right? So would I try this on a very unreliable connection between application server and database? I'm not so sure, right? Again, it's a limitation. There are ways we can check to make sure everything's been written before we shut down an instance or shut down the application itself. But remember, this is the trade-off that you're making. Also, data can't be queried until it's been flushed to disk from those fast ingest buffers in the mores, okay? Also, index and constraint checking happens only when data is written to disk. Then and only then are the indexes actually created, right? Or, updated, I should say, right? By the way, if a primary key violation occurs, no exception gets raised. Because again, we're outside of the normal transaction processing stream. Now, we have quite a few different ways to make sure that everything's been written successfully, but it means as a future-looking DBA, right? If you're going to use this tool, understand its limitations. So you have to do some additional checking to make sure that everything that should have been inserted has really been inserted. Good news is there's some great utilities that we can use to actually do that. I'm just going to take a quick swig of my coffee here because my throat's running dry. I know if it was your time, I'd be having a nice beer, but it's a little bit early to start drinking. On the other hand, I have a friend that has a bumper sticker on his car that says, you can't drink all day if you don't start drinking first thing in the morning. Not me today. Thank you very much. Anyway, I just want to make that clear. I'm a lover of good alcoholic beverages that has a database problem, not an alcoholic that's a DBA. I just want to make that plain. How do I take a look at what's going on inside the mores? There is a view, a dynamic view called v$mem_optimize right area. And I can see what's actually happening inside, how much memory is being used up. So here's an example. As I was running that workload that I was telling you about, that simulated workload, I'm seeing that the total amount of memory allocated to the mores is just about 2 gig. But as you can see, as time advanced, the number of writers, and I understand in later releases, I think at 21C when I ran this test, I think this was from 19C, the number of writers actually reset itself. It didn't continually go up like this, right? But it was an indication of how much work was actually being done by the database, as well as the number of writes. So here you can see that the free space fluctuated between, I shouldn't say free space, but use space. Obviously, these two add together, but use space fluctuated as the writer processes continued to write stuff into the database, right? Actually, finally writing it from those pool areas directly into the tables themselves. Remember, not using commit and rollback transaction processing. We're writing the rows directly into the tables. So this is one way to see what's going on. So if you do run this particular query, you might see slightly different things happening in later releases. Talking with some of the developers that actually worked on this, like, hey, why didn't that writer's number ever go down? So, well, check the next release. So you might see something a little different, but again, it's an idea of how much work is actually happening inside the database. How do I determine, for example, if let's say I wanted to shut down the flow coming in, and I have an application server, maybe I've got a Kafka application server that's taking stuff from a stream, for example, or maybe I'm using Oracle streaming service, OSS, to actually write stuff out and then, capturing that stream and using it to load. Well, here's the idea. There's an idea of low and high watermarks. There's a global low watermark and then a per session high watermark. And the dbms optimize.get functions let me actually figure out where I'm at. So this is a great little query, or really anonymous procedure, PL/SQL procedure block that you can run to see this. So let's see what actually happened here. So I ran this from inside one of my sessions. I ran that anonymous PL/SQL block, and I had not done any transactions at all inside this block, right? I just had another little SQL developer session open, and I was just gonna kick off essentially a solo run of my little PL/SQL routine that would go out and generate the workload. So right now, notice the high watermark for this particular session is 0. Nothing's happening. The global low watermark, however, is at 498, whatever it is, right? That keeps going up, kind of like an SCM, if you will, right? It's analogous to it, but again, it's just a low watermark. And again, this is across the entire instance, right? So now I run some transactions, and you can see that the high watermark is actually above the low watermark. What does that tell me? Right now, those rows for this session have not been grabbed by the writers, the W00N processes, because that's what they actually are, the background processes that implement this transaction processing. They've not been written yet because the low watermark hasn't passed the high watermark. But then after waiting a little bit, right, I stopped my transaction flow. Now notice that, yeah, now that low watermark is greater than the high watermark. If I wanted to shut this session down, right, I'm okay, because everything that could have been written has been written. That's how I actually know this. So that's one thing to look at. Now, I also can control it 2 different ways. If I'm inside the current session and I want to be sure that everything's been written, I can force it with dbmsoptimize.write_end. Now that's at a session level. So if I had several individual sessions, I could encapsulate this in a little function perhaps, or really a procedure inside a package that I've written to manage that application, call this for that particular session. And that will make sure that anything that hasn't yet been written is written. It's an immediate demand on behalf of the writers to go do their thing. I also have dbms optimize admin, note the difference, _admin dot writes flush, writes plural. That indicates to me that this is global, right? At least they kind of did this for me, right? To kind of remind me what I'm calling here. This says, hey, go to every single session, tell the worker processes to immediately flush everything. Why might I do that? Maybe I'm shutting the instance down for maintenance. Maybe I'm making a change to the application globally and I want to implement that. Maintenance perhaps, whatever reason, I do have control over this, right? So I don't have to wait on those writers to actually do what they're going to do. Of course, I would still check low and high watermarks after this to make sure that everything's been written, right? Because again, this is instead of timing and waiting for the workers to do what they're going to do, I'm demanding that happen right now. So what's the end result? Well, what I did is I actually used the inside swing bench. I took the same insert statement, right? I used the same logic to generate transactions. And I built 2 separate PL/SQL procedures inside swing bench. One with the plus memoptimize write hint. And by the way, you must use that hint when you're doing an insert to actually force the use of fast ingest. Now, what if I say insert plus memoptimize _write against a table that's not been enabled for fast ingest? What do you think happens? It becomes a really nice comment. So that hint means nothing unless the table's been enabled for fast ingest. So I really could have done this with 1 statement, but I broke it up into 2 different statements so I could do a comparison here. So you can see that between the 2, right, the top one is the one that was enabled for fast ingest. Same workload. I believe I ran this in about a 10-minute period, if I remember that correctly, that I got a 36% improvement, 7.3 million writes versus 5.3 million writes, just by enabling that table for fast ingest and then kicking off the workload. That's the only thing that was different. And again, If I used that hint but hadn't enabled the table for fast ingest, Oracle would go, nice comment. So I could have done it that way too, but this way I can actually, you can see how that breaks it out, because I used an AWR diff procedure to actually generate this difference report, right? So here you can see that just by adding that one hint, I got plus 35% improvement. A little bit of a deeper look. Notice that this one get a little tricky to actually figure out. By the way, notice that this table, T-meter readings, is partitioned. I used a range partition, and the newest partition I think was based on a date in, oh, I'm trying to remember. I think it was like early February, like February 22nd, which is the date I first did this presentation on. So anything after February 22nd, so this would be February 23rd and beyond, would be written into this particular partition. So just to keep everything fair, right? So here you can see that there were fewer physical rights overall, but I inserted many, many, many more rows overall into that same table. What I did is, in between tests, by the way, is I just simply truncated the partition, right? So you can see here that in the same amount of time, I inserted quite a few more rows, right? I inserted many, many more rows based on that earlier slide I just shared with you, or part of the report, but many fewer physical rights. First was 670,000 physical rights. In the second test, which was the one for fast ingest, I did it with only 12,000 physical rights. So that gives, I'm sorry, did I misstate that? I'm sorry, 83,000, almost 84,000 versus 12,000. I'm sorry, I was looking at first total versus the other one, but you get the picture here, right? It was a significant difference of about 71K, almost 72,000 fewer physical rights using fast ingest. And again, it's because of the way we're doing the rights, correct? Because we're not doing it using the traditional transaction processing. So that's a pretty fair comparison right there. And that pretty much gives us a good picture of how fast ingest works. I'm going to pick up speed a little bit here. I know I've got time, but I don't want to waste your time. It's valuable. I want to talk about fast ingest's cousin called fast lookup. Fast lookup is in many ways in a complete inversion of fast ingest. It's designed for very quickly reading data. And we'll talk a little bit more about this, but here's the basic idea of how I simulated it, right? Imagine the same scenario I've got, right? I'm using mem optimized for write for fast ingest here against the T-meter readings table. But what if I had some data that was part of, say, the smart meters table that was quite large? Or I had a related table that had some information that had a big chunk of data as part of one row. And I'm going to constantly hit that all the time. I can use fast lookup, which still leverages, by the way, the mem optimized row store, but not for writing, for reading. So it's almost completely inverted, right? First off, not write, read. And secondly, not huge amounts, one row at a time. So we can actually leverage fast lookup and leverage the mem optimized row store if we're using it for fast ingest as well. So what's the difference? Okay, fast ingest is drinking from a fire hose, isn't it? That's basically what it is. Fast lookup, as I said, is exactly the opposite, but they're related because they use the mores. So if I make a table ready for mem optimized read, any fast lookup request, anytime I go to access its data, builds a hash table of primary key values. Then the rows themselves, not the blocks, the rows are written to separate buffers in the mem optimized row store, and they're pinned. So they're added to separate buffers, but not the blocks, just the rows. The hash table is thus a shortcut to reading that row directly from a corresponding buffer. Much faster than, I know what you're going to say, why can't I just do a keep? Why can't I just pin that buffer? Because I got to pin the whole stinking buffer, right? If I have a row that, or a block that has, say, 200 rows in it, and I want to pin it, but I might have to pin that whole block into the database buffer cache, but I only want one row. And so when would I possibly see this, right? I compare this to the difference between drinking from a fire hose, right? Fast ingest, and I want one grain of sand, one stone off the beach. So here's a couple of examples, right? Think about this, because I think about this all the time. I just picked up a new streaming service. I was been watching some things, and guess what comes up on the streaming service? Here are recommendations on Mr. Czuprynski, what we think you'd be most interested in based on some algorithms, right? Or here's our latest releases. Here's our latest theater releases. My wife and I really enjoy watching movies, right? So here's our latest releases. What do you think is going to be hammered the most? Latest releases. We release a new product. We release a new model of the Volkswagen ID.4. Hey, what do you think people are looking at? 1983 Subarus? No. They're looking at a 2021 or a 2022, perhaps, model of the car. Maybe most recently loaded rows would be another example, right? Most stores that I know, if we're doing an analysis for sales, are looking at what happened yesterday, what happened in recent history. Especially if, for example, the one I'm going to share with you is simulating with a table that I gathered data from and then essentially populated into, I believe, a Vercare 2000 column, right? 2000, Vercare 2000 or 1000, I forget which, but it's just a big chunk of data, right? A big character field. And maybe that's one that we're constantly hitting, right? That we're hitting up against. Here's another one. What if it was a map? What if it was an image? What if it was a chunk of JSON? You know, ultimately a map is nothing more than a JSON object. Really, that's what it really comes down to, right? What about for, hey, how do I get to this event that's happening today? Tomorrow it's going to be another event, but today it's this one. That's the beauty. That's the beauty of using fast lookup. So how do I enable it? Well, guess what? Here we are again, some unexpected errors. Okay, I'm going to turn on the smart meters table. I'm going to turn them on mem optimized for Oops, I had forgotten to add a non-deferrable primary key constraint on the table. Oops, that's right. Got to have a primary key because that's what we're going to build the hash table on. So if you don't have a primary key, you're going to get this error. Okay, I added the primary key. Let me try this against team meter readings. I'm going to enable it because I'm going to use some of the, I'm going to use the most current, the data from the most current partition. And oh, one of the partitions for this particular table, because I remember I told you team meter readings was partitioned. It had not been populated yet. So there were no rows in that particular partition. And this goes, dude, sorry, you cannot use fast lookup if even one of those partitions is not populated with at least one row. So where can I find a list of all these limitations? They're not there yet. I looked a couple of days ago. Unless it's changed, the only way to really get a handle on what these limitations are, my best bet is go to Oracle error messages for your release of the database and look through all the error messages from 62.100 to 62.200. And you can see from those error messages what you can see as the expected limitations. It's the best I can do right now. Sorry to bring you bad news. Here's some other things you need to know about. Even though you enable the table for fast lookup, you have to populate it. So if I want to load the T meter readings table from the semiot schema, by the way, no, you can also load just the partition. If I leave it at null for partition name, I'm going to load all partitions, right? This populates all rows as candidates into the Moore's pool. If I wanted to remove it, I could use the dbms optimized.drop object. And remember these two procedures because I'm going to show you some other data here so you can see what's actually going on inside the pool. Here we go. From my particular instance, if I look for everything that says mem_opt_r inside the name column for $systat, I can see what's going on underneath the covers. Oh, okay. What's happening here? Well, 36 entries were deleted. Why? what's going on inside here? I use the drop object procedure to wipe them out. Notice there was also a statistic here for lookups, for misses, for populate tasks accepted. Oh, right there, that memopt_r populate tasks accepted. That is the indication that at least 4 times I said for a particular table, hey, tell me, I'm sorry, not tell me, please populate this table. I called the populate procedure to actually do it. A little bit more detail. This query, by the way, you're going to have to run if you're on a database. Make sure you run as admin, okay, or somebody with DBA privileges, but at least admin privileges, right? You can't see this from an individual session. It has to be somebody at a, not necessarily DBA level, but an admin privilege level, which again, if you're working inside the cloud, you understand where I'm coming from. This was after I did a rather large run of fast lookup procedures. Again, I use Swingbench to do this, and you can see all these marvelous statistics. Oracle knows exactly what's going on. And oh, here's the key thing I wanted to point out. Notice that the W processes there, right? There's an example of these background processes actually doing the work underneath the covers for fast lookup. By the way, if I just change that particular query to include memopt_w, I could also filter for all activity that the database is doing inside for fast ingest. So memopt_r for fast lookup, memopt_w for fast lookup. So just you know, there's statistics. It doesn't mean anything except work is happening, right? And that rows were populated and that they were being consumed. So what? Well, here's what. If I run this particular query, now what I did here is I built a table called tsmartcos. Small table, had only about 50,000 rows. And I basically grabbed just the smart meter ID, and then I built a simulated chunk of text. I think if I remember correctly, it was a varchar 2 1000 chunk. And I just populated with varying wildly lengths of the typical ipsum locum type of text, right? I just built a little text generator, variable lengths inside there so that it, you know, it'd be a fair fight. If I say, show me all data for smart ID between 2688.079 and 2688.081, notice what happens here. That's a range scan. It says, hey, okay, range scan, I can't help you. Oh yeah, I mean, I can use the index to quickly scan and find those rows, but I'm not going to do fast lookup. But if I say exactly equals this smart ID, SMID equals 2688.080, note, here's what happens. Now I've got a by index row ID read optimized. Unique scan read optimized operation follows that. That's a direct indication that fast lookup was used. So here's a good trick, right? It's your developer goes, hey, you know, I wrote this thing, or your junior DBA puts this together. Fast lookup doesn't work. It stinks. Did you use an equality case, or did you use a range scan? And by the way, not equal doesn't work either. Only equality works this way. Now that could change in the future, but right now, remember, what's the idea? Single pebble off the beach. That's what I'm really trying to do. The sort of the opposite of drinking from the fire hose. And how can I leverage some of this stuff? I'm going to go through this kind of quickly because we've only got 10 minutes left in the hour. What I did is I took some of these data and I expanded this out into another presentation I'm working on. I wanted to identify people, really customers, individual smart IDs that were solar super users. I had data that was coming in as part of my smart meters that I was reading that said, here's the people that are using solar panels that a particular public utility issued, right, of at least 15% of the time. So I said, if 15% of your energy was coming from the solar panels that we installed for you at great cost using government subsidies for electrification, we consider you to be a solar super user. So I built this little view from a couple of my tables, my separate little tables here. And then I built a k-means model what am I thinking? Come on, Jim, think. I built a machine learning, there we go, machine learning model using the k-means algorithm to find how well or how clustered, shall we say, right? Are there groups of companies that are leveraging their power, their solar power, more effectively? And here's the actual implementation of this particular OML for SQL model that I built. And what did I use this for? To do some analyses. So for example, now that I know who the solar super users are, I can see which businesses either really used a lot of solar power, or actually in this case, since I know who the super users are, I looked at, show me the businesses that are not using it. They installed solar panels on their roofs. We helped them. We gave them a subsidy, and they're not using it. This is a centroid-based analysis. So these are people that are literally, if you take a look at this, right, this graph. By the way, I did this inside Apex. I built a little app called IOTA. Remember IoT, right? That's what I named it. And what I'm showing you here is there are several people here, several solar power non-super users that for whatever reason are not using their solar cells, solar panels as effectively as they could. And what I did is I used that business classification entity to basically break it down. And some of these kind of make sense. The one all the way almost near the bottom right-hand corner, operation of a commercial passenger vessel. It's actually a seagoing vessel. We have rivers through Chicago, and we have several folks that run water taxis, right? So yeah, I can imagine maybe they're not using solar power that much, but again, we're looking at using these data to figure out in real time where the negligent or the not solar power super users are. And I could have essentially used that model and tweaked it a couple of different ways to actually look at who are the people that are egregiously overusing solar power, right? Again, my point is these data are meaningless without some sort of analysis, right? I mean, the reason we're collecting it is to make sense of it. And finally, one last one. And by the way, I incorporated this a lot in another presentation I did on Apex. And I think I'm doing it, that one coming up for the Chicago Oracle Users Group in about a week and a half or 2 weeks, I believe. Here's an example of using Oracle's erstwhile geolocation mapping, inherent mapping. Did you know that you could use, you don't need to use Google Maps. You can use Oracle's built-in spatial and graph tool sets within Apex. And all I needed is there's a little query that just basically pulls this information in. It shows here who are the solar super users, right? These are the top 25 people that used the most solar power throughout the city. Now, again, this is simulated data, but I just want to give you an idea that we can drill in with these data and figure out, well, geez, these people, I don't know if I had it on this one here. I think I used actually a range of, gold. I don't know if that gold one is maybe covered by that label there, but, gold was like the super users. Green was, well, they're using 25% solar, and anything below 25% was light blue, and where they're actually located on a map, right? Again, the presentation I did for Apex and using these mapping things, is another great way of analyzing. Is there some sort of geographic clustering? Here's another reason this might be important. Let's assume that I've got service centers and someone goes, my solar panels aren't working anymore. Maybe the reason somebody's not using the solar panels is because they're not working. Where's the closest dispatch center? I need to find that on a map, wouldn't I? The really cool thing about utilizing fast ingest to get the data loaded in quickly is I can see in real time where the highest users are during a particular period of time. That's for a different presentation, but I just want to share with you with some of the stuff that we can do once we've got these data loaded. I've got some future experimentation planned, by the way. My colleague Dominic Giles, who's moved on to Google, actually has a new workload generator. I'm going to be using this, hopefully against an ATP instance once they get that little issue with the encrypted table spaces figured out. I want to do that. I'm also going to be playing either with OSS or Apache Kafka instance to actually really do real world streaming against this, right? Because my test platform works fine, but using Swing Bench, but I would like to actually do it in real world, real life with a real streaming service instead of just simulating it. And then there's some other documentation here and some really interesting reading, by the way, on many of those key points that I was telling you about. If you're interested where IoT is going, it's pretty amazing. Now, again, American suburbs about to look a lot more like European cities. If you're in Europe, you're going, well, it's about time, but, you might as well figure out how to use those bikes, you doofuses over in the US, but we're figuring it out. We're working on it. Some interesting stuff here. That's basically all I had for you. Let me see what we have in Q&A.
Yeah, Tim, there's at least one question and
okay.
two. So are you going to read it?
Yes, I'm looking at them right now.
Okay.
From Menzel, I believe I'm pronouncing that
you
right.
did.
If a table is Judith. If a table is defined as mem-optimized for Mead, when changes are performed on the table, are they reflected automatically in the memory buffers? Ooh, that's a good question. That is a really good question. Off the top of my head, I don't know the answer to that. So like if somebody made a change, again, we're not saying using mem-optimized for write, but if I updated the data, would I have to reload? I don't know the answer to that. I will experiment with that. If you could, can you send me an email at, and I promise I will get back to you. Let me go back up to here just for a second. If you've got my, let me put my, inside the chat, I'll put my email address and you guys can, where did that run off to? Here we go. I'll throw it in the chat if you want to catch me. Please send me an email and I'll research that because I'm not sure. That's an intriguing question. My guess is, just a guess, it's 50-50. I honestly don't know because you could, right? I mean, really the hash table's already built for the primary key, but would the data be there? Wow, I don't know. I don't know. I'm leaning 60% you'd have to repopulate. Yeah, great question. Great question. And the other URLs into the chat, Mr. Bacher, which URLs?
I think all the URLs you've given me the presentations. I've made a PDF of it, and I'll make sure it gets it becomes available for everyone to download.
Absolutely, absolutely, sure. Okay, and I have 1 minute left. Any other questions? Seriously. At least you know now what fast ingest and fast lookup can and can't do, except for that last question. Okay, well, I'll give it back to you, Patrick.
Yeah, I've already taken over the screen, I think.
I noticed.
Thank you, Jim. Thank you, Jim. And I hope to see you in about a month or so, doing another presentation. And that time you will do that one. So be prepared.
Yes, I will. I will.
Next week we'll have Menno Hoogendijk, who was used to be a colleague of ours and is now part of the Oracle Apex team. He'll do a presentation on the top 10 new features of Apex. And we'll have Jeff Smith coming up with 2 presentations, Job Oprel doing the presentations, and there's probably going to be a couple more. So hope to see you all next week. And for now, thank you.
Stay safe, everybody.